Hi, this is Tim, and welcome to the first live stream that already is having a few technical difficulties. Can you hear me? Is the sound okay? Anybody? Maybe put it in chat if it is horrible. But okay, I'm a little flustered, so give me a second. Hi, this is Tim, and welcome to the first live stream that already is having a few technical difficulties. Can you hear me? Is the sound okay? Anybody? Maybe put it in chat if it is horrible. But okay, I'm a little flustered, so give me a second. Hi, this is Tim, and welcome to the first live stream that already is having a few technical difficulties. Can you hear me? Is the sound okay? Workbench. This is something that anybody? A lot of you maybe put it in chat if it is horrible. It's not something that I could. But okay, I'm a little flustered, so give me a second. Hi, this is Tim, and welcome to the first live stream that already is having a few technical difficulties. Can you hear me? Is the sound okay? Anybody? Maybe put it in chat if it is horrible. It's not something that I could. But okay, I'm a little flustered, so give me a second. Hi, this is Tim, and welcome to the first live stream that already is having a few technical difficulties. Can you hear me? Is the sound okay? Anybody? Maybe put it in chat if it is horrible. It's not something that I could. But okay, I'm a little flustered, so give me a second. Hi, this is Tim, and welcome to the first live stream that already is having a few technical difficulties. Can you? Was here, they could do that for me. Is that better?
Keeps going in rounds.
Okay, how about now?
It's still doing. Hi, this is Tim.
What? Oh my goodness. Okay, well we are definitely maybe shaking out some of the errors already. Apparently it is going okay, now you can't hear me at all. Oh well, yeah, let me see. Can you hear me? Or what do I sound like?
It's better.
I don't hear anything.
I don't hear anything now.
Yeah, so apparently it is going okay, now you can't hear me at all? Oh, well, yeah, let me see. Did you hear anything? Can you hear me? Or what do I sound like? Okay, so maybe we're working through some of this. So, all right, so I'm hearing, is this better now? Apparently it is going, okay, now you can't hear me at all? Oh, well, yeah, let me see. Okay, there we go. Did you hear anything? Can you hear me? Or what do I sound like? Okay, so maybe we're working through some of this. So, all right, so I'm hearing, is this better now? Apparently it is going, so yeah, we've got some okay, now you can't hear me at all? Do many of these. Oh, yeah, let me see. But we will get through it. Oh, you want this back? Thank you so much. Thank you, everybody, for your patience. But okay, yes, so we are going, let me see if I can do this screen. Okay, can everybody, I guess hopefully you can see the screen now. And this isn't a complex program by any means. That's why I kind of thought it would be a really good one to try this with, is it's got 5 subroutines, and it's fairly basic. So let's just take a moment to go through it. The main routine really is just breaking into various different subroutines. And we get some scaling because there's some analog. And yeah, I mean, all of it's fairly basic, but all right, we got some sequencing. And so we can, talk a little bit about sequencing. Okay, and I didn't say, if you have any questions, feel free to put them in the chat. I'll try to remember to look over occasionally and answer them. Let's see, then we have an output. This really is just grouping all the code together. Here's all the outputs for it. And then there's some alarms. And so we've got an identical system, but in this case they wanted it to be with the Micro850 PLC. And so a couple things. First, there is an automatic conversion, and I really dislike it. In fact, let's just go through it. It doesn't take but a second. It has this Micrologix to 800 converter. And let's see, let me export the file. So to use this, you get a file and you're going to save as. And then typically you're saving as an RSS file in Rslogix 500. In this case, we're going to save it as a SLC file. So we're going to save. And then we're just going to select that file over here. And our documentation will be the same. And in this case, we're using a 2080 LC50 48QBB. And so it does import everything, and you can see we've got, we got about 42 warnings that we need to go through, but let's just look at it some. Honestly, I haven't really looked at many conversions on this, but okay, it is breaking our subroutines into user-defined functions, and probably that is the best way. That's not how I'm actually going to do this program. I'm actually just going to make multiple programs. And now I hadn't actually looked, but all right, it does make kind of a TON conversion. That may even be worth a video. As yeah, it is converting the TON into more of what we're used to seeing in Rslogix 500. Let's see, scaling. Again, it doesn't look bad. You can see it couldn't figure out exactly where this analog input was. There'd be some mapping. But here's where I start to have a problem with most of these conversions is this was F80 in the previous program. And that is how the data structure works in Rslogix 500. But we have so many more options in Connected Components Workbench with tag-based addressing. So I see conversions done like this, and they just don't make a tremendous amount of sense. And if we go on into sequence, you're probably going to see some of the same thing. Yeah, so in this case, if we go back to our Rslogix 500 program and sequence, let's refresh my memory here. Then yeah, we were using actually a long integer to sequence through this, and it was L90. Now I wouldn't use L90 if I could name it something. I would probably name it sequence. So while this does get you the rough structure for your program, I think you're going to spend a lot, either one of two things are going to happen. You're going to spend a tremendous amount more time trying to straighten out the addressing, or you're going to put it in there like this and really hate yourself later down the road when you need to troubleshoot it. But okay, so let's just close this out. And then we're going to start a new program. And we'll just call this PH. And we're going to create it. And then for my controller, I have a Micro850 PLC. And it's going to be a 2080 LC50 48 QBB. That'll be it. And this is, because somebody asked me when I posted that I was going to do this, so well, why would you not just use another Micrologix 1400? This is a neat new feature of version 13 is when you select these, it'll tell you whether they are actively supported or whether they're on the obsolete list. And so the Micrologix series, the 1100 and the 1400 are on what is called active mature. And that means that they are still supported, but there is not going to be any further development done on them. And so in those cases, they're great for obviously replacement PLCs, and they're still good PLC, but looking into the future, they're on their way to being phased out. So this is a neat new feature, though, is it tells you right here whether this is an active model or whether, I assume it would show that it was active mature or something else if it wasn't. So we're going to select that, and we're going to be using version 12 and add to project. And just to add another variable into this is actually version 13 of Connected Components Workbench, and it's the first program I've written with it. So we'll see if there's any pitfalls to that. Okay, if we go back to our program that we're converting, we're going to start by just building out this structure. So we have a main routine, a scaling, a sequence, outputs, and alarms. So we're going to create those, and I'm not going to do it in the user-defined ones. You could do it that way, and that probably is a more direct conversion, but I'm just going to create programs for each one of them. So I'm going to right-click, add, and I'm going to add a ladder program. And then I'm going to name it main. And then we're going to right click, add, and we're going to add our scaling. And honestly, I know this is supposed to be a direct conversion, but scaling in math, I'd usually do under structured text. And then I'll add a little variety. So let's create a structured text program, and we'll call it, let's just call it calculations. So that'll be the one that we do some of our math in. Then next we have sequence. Right click, add, ladder. We'll call this sequence. And then outputs. And finally, we have alarms. Now, unlike if we had made these user-defined function blocks, in this case, each one of these programs is going to be executed. And they're going to be executed in the order that they are here, which means it's going to be pretty much the same, because up here, if we go to main, well, we have an AFI, which is an always false input, and we won't even need that in Connected Components. But really, this program jumps to the scaling, and then to the sequence, then to the output, and then to the alarms. And that's the end of the program, and it's going to come back around and do it again. So this is going to do the same thing. We're going to execute the main, calculations, sequence, outputs, and then alarms. And then we're going to do it again. And it is in exactly the order that you have them here. So if I take the outputs and drag it up above sequence, that is going to change the order of operation of that. So I'm going to put that back down. But yeah, then if we actually look, we're done with the main program. Now, chances are when this machine actually goes into service, there'll be something in here, and I don't even know what it'll be. But we're actually done with the main program because we have the always false input, and we've replaced our JSRs with these. So now let's go on to our scaling. So in our scaling routine, it looks like slot 2, input 0. All right, that was our tank level, and it's 0 to 5. So we're just going to do some, we're going to make a structured text example of this. Oh, but I didn't add my I/O module. So yeah, I created the Micro850 here, but down here I have an expansion module. I have a 2085 IF8. All right, and let's just go ahead and look at what we have and what we're using. So we're using 1, 2, 3, 4. Looks like we have 4 of those inputs we're using. And it looks like they're all set up for 4 to 20 milliamp. But if we're not sure, we can double click on our I/O configuration and then double click on the 1762 IF4. Go to analog input, and yeah, we're 4 to 20 milliamps on all 4 channels. All right, so channel 0 is enabled. I think all these are probably enabled by default. Yeah, and I'm just going to leave all of them enabled. They're all default configured for 4 to 20 milliamp and for engineering units. And so I should have got that up already, but engineering units, let me just Google 2085-IF8 scaling. Just make sure I'm right on this. Yeah. Okay, so if we look here, here's the manual. We have, here, what are we on? Page 8 of, let me go back up, what manual is this? Google's awesome, but sometimes I don't get all the details. The Micro800 expansion I/O modules. And if we go down to page 8, then we can see what our engineering unit scaling is going to be. So we're configured for 4 to 20 milliamps here. And at first it may look a little weird because the scaling is showing 3200 to 2100. But if we look down here on note 4, it says the full range value of, and a 4 to 20 milliamp is going to be 3.2 milliamps to 21 milliamps. So that's where we're getting this value from. 3.2 milliamps is 3200 and 21 milliamps is 21,000. So 20 milliamps is going to be 20,000 and 4 milliamps is going to be 4,000. We can scale it in between there. All right, bring that over here. Okay, so let's go into what we label our program called calculations. And then, yeah, we need to, well, we haven't even talked about where I/O is. So now, and I didn't even catch this. So I'm in version 13, and all of a sudden it was a little bit of a struggle because I normally use the Logix view. So I'm going to switch over to Logix. And I got to tell you, Rockwell, y'all have done a great job of really massaging this. This is really starting to look a lot like Studio 5000. So that's why I love this view. It makes it really easy to bounce back and forth between the two softwares. But so, just like in Studio 5000, our I/O is all going to be up here in our controller tags, or controller variables. And if we double click on it, here are all of our, well, first our outputs show up. And I've never figured that out exactly, but we're going to start with our outputs, and then right below it is our inputs. And so what this actually says is I/O, which means it's part of our inputs and outputs. EM, which is means they're embedded. And then we have a digital output, and here is 0 through 19. And then right below it, we have DI for digital input. And we're going to have 0 through 27. And then we scroll down a bit more. We got some system variables here. But then we have IOX1. And what that means is this is your first expansion module. So up here, oops, how do I get there? There we go. I added an expansion module as that IF8. And so when we look at it, expansion 1, and it's an analog input, and there is 0 through 7. And so these are going to be the ones that we're going to want to scale. We ought to go ahead and, actually we should go ahead and put some descriptions in before we go too much further. So if I go over here, and well, I can see them all here, but let's go ahead and right click and go to data table. And input number 2 is going to be tank 1 level raw. So I'm just going to go over here and I'm going to label this one as tank 1 level raw. And then we have tank 2 level raw. And then we have tank 2 pH. I actually have a spare there. Okay. So tank 1 level raw, tank 2 level raw, and then tank 2 pH. And then let's go up and level and label all of our description, all of our inputs and outputs while we're at it. So if we just use our box down here in the bottom left, we're going to go to outputs first. So O, and then let's see, we have 0 is a spare. And then 1 is going to be an alarm light. And then 2 is going to be a buzzer, then a spare, and then pump 1. So alarm, buzzer, spare. Whoops. Okay, now, so I am putting these as aliases. And what's really cool about doing this in Connected Components is it makes it where you can type the description or you can type the actual address. Now I can put it over a comment, but I don't want to do that. So I'm going to change spare here. This is going to be spare 03. And then we're going to change spare up here to spare 00. All right, so the number 4 was pump 1. And number 5 is pump 2, and then chemical pump. All right, the number 7 is going to be valve 1, pump 1 to tank. And number 8 is valve 1, pump 1 to tank 2. All right, so valve 1, pump 1 to tank 1. Then we have valve 1, pump 1 to tank 2. And then number 9. All right, valve 2, pump 2 to tank 2. And valve 2, pump 2 to effluent. Valve 2, pump 2 to tank 2. Valve 2, pump 2 to effluent. And then we have a number 11. All right, it's spare. So 1, I'm going to hit, let's drag this out just a little bit. There, so we can see it all. And I'm going to hit the usage here. And okay. So those are the only outputs that are used on it. And okay, then our inputs down here. Let's see. Actually, yeah, because I'm trying to think. I don't think there's any discrete inputs used on this. Oops, no, I'm on outputs right now. No wonder I'm like, this doesn't look right. But no. Okay, let's go to there. Okay, there are a few inputs used on it. So we have input 4, which is emergency stop pressed. And before somebody says it, no, the emergency stop on this is hardwired. This is a signal to let us know that it is pressed. So input 4 is going to be emergency stop pressed. And then input 5 is going to be 24 volt or 24 VDC power OK. And then we have an alarm silence, and number 9 is a downstream interlock. Okay, so I think that covers all the descriptions. I'm sure I missed some, but that'll get us going. And all right, now we could start on the scaling here. So this first one was scaling from 0 to 5. And here we were putting it to F80, but we want a little better description than that. So we're going to go here. And then we want to look at that. So if we hit underscore IO underscore, and then remember it was X1, that gets us there. Now if you're not sure, you could have just scrolled through those. If we just hit underscore, then we can see everything, and we could go hunt and peck and find it, or we can type it in, whichever is easier on you. And so this is going to be analog input number 0. And then we're going to need to subtract. Okay, so 4 to 20 is what we call a live 0. And what that means is when it is 0, it is at 4 milliamp. And when it is at full range, it is at 20 milliamp. So we need to subtract that 4 milliamp, which if we go back and check our engineering units on this, then we're on 4 to 20, or where was that? That was on that manual. So in the manual there, it told us that we are going to be 4,000 to 20,000. So there's where those numbers are going to come from here. So we are going to subtract 4,000 to take that milliamp signal out of it. And then actually I'm going to put some parentheses around that because I always seem to mess up order of operation. So I'll probably have too many parentheses, but that's okay. And then we're going to divide it by the full range. Now the full range is actually 16 milliamps because it's 4 to 20. 20 minus 4 is 16. So we're going to put 16,000. Actually, you know, I don't know that I would do this, but for clarity, we can put, and also name in parentheses, 20,000 minus 4,000, which is going to be 16, but maybe when I'm looking at it, you know, years down the road, that might help me remember. So that's going to get us actually into a percent of full scale. And so now we need to multiply it by our full scale. And that was that 5 feet? Yeah, so we're 0 to 5 feet here. So we're going to multiply times 5.0. Oh, and we need somewhere to put this, don't we? And I got a little ahead of myself on that one. So we are going to create a tag, and let's just call this tank 1 level. And that's going to equal colon. So we need to create tank 1 level. And I'm going to make it a real. That way we can get a decimal place on it. All right, and then I will probably forget this 10 times during this live stream, and is at the end of this, you need a semicolon. And that tells it that, okay, you're done with that line, let's go on to the next line. And especially when doing structured text, it probably doesn't hurt to hit the verify button occasionally. And then I got here, tank one level must proceed. Oops, what did I do there? Oh, I got that backwards. Oh, well, here you go. So the disadvantage of the live stream is, all right, what did I do? Invalid right argument expecting. Oh, because, okay, this is a good one here. So when I hit the verify button, I get a bunch of errors, and that can kind of get intimidating because, okay, this thing right here must precede a real expression, and then it's talking about is expecting, you know, byte or something. Is if we go and look in our controller variables at our expansion modules, they are integers. So they are whole numbers. And so when you're manipulating data, you have to stick with whatever you have. And so what we need to do is convert this integer into a real. Or we could specify everything else as an integer. And I do see that done, and then people will like multiply 10 at the end of it. But that's not really, I don't know, I guess it doesn't matter in the end, but I think it just looks better to say 5 or 4.5 feet or something. So what I'm going to do is I'm going to go to the beginning of this, and I'm going to type any, and you're going to see all the any instructions coming up. And if you're not familiar with those, we got some videos on those. But we're going to find the any to real. And we are going to any to real that value. And now we'll hit our verify. Okay, and that error goes away. Now the colon, the semicolon, that's the one that usually whips me. And yeah, so let's take the semicolon out just so you can see what that would look like. So if I hit the verify now, expected, or semicolon expected before this new statement. And if we double click on it, it gets us close to where it is. And really, if I see that, I just start looking down the lines, which obviously we only have one right now, but start looking down those and chances are you'll see it. So now we're going to copy and paste that a couple times because our scaling will be similar. In fact, our tank levels will be exactly the same. So let's go ahead and create tank 2 level, and it's going to be a real. And then we're going to have tank 2 pH, and it's going to be a real. And we'll go back to our calculations. All right, so the second one will be tank 2 level, and it is the second input on that expansion module. So, well, let me make sure I'm not making a big assumption. I assume the scaling is the same. 0 to 5, 0 to 5. Okay, and then we have a pH, and our pH scaling is 0 to 14. And I really wish, actually, I had a scaling that the lower number wasn't a 0, because that's probably a good thing to go through. But we'll save that for a different video. So this one will be tank 2 pH. And we are going to multiply by 14 instead of 5. And go ahead and hit that verify again. And hopefully I got my math right there. Like I said, you know, we won't be testing this today. This is more of let's write the program. But I just realized as many times as I have told you guys to do this, I forgot the most important thing in Connected Components Workbench is I did not set my IP address. So we need to go into our controller here and go to our Ethernet setup and configure it, because right now it's configured for DHCP. And so If you download a program that's configured for DHCP, you're going to need something like our SIM IPE to write a new address to it. So we're going to configure it for 192.168.110, and our subnet's 255.255.255.0. And this one doesn't need a gateway address. But all right, I think, no, there was more to that. I was getting ready to say, I think we're done with our calculations, but no, there was something else down here. Okay, so we are settling time in minutes. Okay, so we're making something probably for an HMI screen. Yeah, okay, this was probably read in the HMI. So I'm going to right click F8.5 and figure out where this is used at. So go to cross reference. Okay, and so this is the only instance this is used. And if you see something in a program that is the only instance it's used and you're like, well, they're not actually doing anything with it, don't ignore it. Because it could be connected to a larger system, such as a SCADA system, or in this case, there's an HMI that tells you how much more time there is that this needs to settle before it's going to run on through the process. So this is going to be I really want to go make that timer first. So what I'm going to do is I'm actually going to create just a spot here, because we'll get to that timer fairly quickly. Oops, except for, okay, now, see, here's where I didn't review this, but I still think I like the way I did it, because I really wonder why that timer is where it is I don't want to do that in structured text. I can do that in structured text. I mean, all I'd have to do is put the timer value divided by 60, and we would have it. And I don't know. Actually, yeah, I probably would do it that way. So what I'm going to do is I'm going to go over here to our sequence, because that's where it comes from. And I am going to go to the timer tab and bring down a TON instruction. And immediately when you make a TON, it names it something, such as TON_1, which is okay, but it's not necessarily the most intuitive thing to find later on. So I'm going to go to my sequence here, I'm going to go into my sequence here and open up the local variables. So that's where because that's where that's created at. And there you go, we have TON_1. Now, if I go back over to my program and kind of figure this out, yeah, so this is our settling time. So I'm going to rename this timer from TON_1 to settling time. All right, now that just, makes it so much clearer what it is. And I see a lot of programs that they're TON1, TON2, TON3. I just think that makes it a lot easier to understand later. So now let's go back to our calculations. And, well, one, we need to create a controller variable. And I do want these to be controller variables, these particular ones, because this is something we're reading from elsewhere, or we're sending elsewhere. So this is the settling time in minutes. Now, you may be tempted to make this a time data type, but this actually isn't a time data type. This is a real. We go back and look at our original program. It's F8.5, and F8 is a floating type variable. And so that's going to give a decimal of how many minutes are left. So now let's go to calculations. And we're going to put that our settling time in minutes is going to be equal to settling time. Ooh, all right. So I made a mistake there because, yeah, I need, I said that was in a local variable here. And there's where, yeah, I said earlier, I think I would put this over with this one. Because really, I like to group kind of stuff by its function, and this was probably added later, and honestly, I did write this. It was added later without a lot of thought because somebody probably wanted a timer. I'm like, yeah, throw a timer in, throw it on the HMI, and we're done. But no, I would actually normally, if I was writing this from scratch, and here's why I don't like the automatic conversion tool up here, the Micrologix to 800 converter, is really, this is one of those cases, that little glance of it, I just realized, okay, that could have been done a lot better. So I really do want this down here in this sequence, and I probably want it right here with this. So I would probably put a branch here, and then I would bring down an instruction block, and it would be a divide. And okay, first we need to assign this elapsed time. So we're going to create a variable. And this will be settling time in milliseconds. Yeah, ms. And so I'm going to make that a dent. And then we're going to take that same thing, we're going to put it right there. And then make sure I'm on the right track here. Yeah, okay, that was divided by 60. Now, this is in milliseconds though. So we're going to need to divide by 60,000. Or, can I do that here? Yeah. Or, I know I want 60 seconds. I can put T number 60S. And that's going to tell it 60 seconds. Oh, and it doesn't like it because that's a time data type. Okay. So it would have to be 60,000. And then we're going to put that in settling time in minutes. Okay, now you notice right now there is no preset time. We'll come back to it. Right now I'm trying to still get to that calculations program. I think there was one rung left. Okay, so then we have a downstream interlock. Okay, and it looks like both of these were probably added at the same time, and they really have to do with more of some HMI signals that were needed. And, I was probably thinking there might be a multi-state needed eventually, but it looks like I only used 2 states. Here we're going to keep it like that. But I'm going to move this, well, I'm going to move it to the alarms program because I think it makes more sense there. The alarms are really mostly HMI indicators, and this is an HMI indicator. So there you go. Now you know, guys, my programs aren't perfect. But all right, so we're going to go to the alarms. And that was going to be input 9, so we'll go to the I/O tab, and we're going to go down to our inputs and find number 9. And then we're going to bring an instruction block down, and this will be a move. And in this case, let me make sure I got these straight. If we have a 1, or if it's examine if closed, then we put a 0 in. So, okay, that one's wrong. But we're going to use it in a second. So let's go and put a branch in. Drag that and that. And yeah, we're going to put a 0 here. Copy that. I'm going to paste it here. Oops, got it on the wrong side. There we go. Okay, and this needs to go to, I believe that was an integer. Yeah, so N78. Okay, this is downstream interlock status. So that's what I'm going to name it. So I'm going to double click here. And it's going to default to local variables, but I need this on the HMI, and so I'm going to make it a global variable up here. So downstream interlock status. And that will be a dent. Put that there. Okay, and then, is that it? That is it. So that's it for our scaling. So next we're on our sequence program. All right. So this one, what type of, okay, so this is, and I thought, man, we ought to do a video on this. We did some binary videos, but this is actually putting values into an integer. Actually, this is a double integer to shift bits, and that's how it's tracking it. So yeah, this is actually a pretty good one. Maybe we will set this up on a trainer and see if we can do some simulations with it. It might be a good one to kind of talk about sequencing some more. But all right, we're going to start with just building out this basic structure. So we have an XIC, greater than or equal to. We have a timer, and we have a move. It'll be a miracle if I remember all that, but let's try it. Okay, so we have this that we've added, this settling time, and we'll find a home for it in a little bit. For now, let's bring a rung right above it. We have an XIC. I'm not going to worry about, I'm just trying to build the structure right now. Then we have a greater. Is it greater or greater than equal to? I can't remember now. It's one of the two. And then we end up with an output. Oops. And then we had a timer. No, we don't have an output. We have a move over here. Well, let me just go back and look. We have a move. And then there was a branch. Oops, didn't get that right. Timer goes in the top. And there was also an examine if closed. There. So let's see, is that the right framework? I think that's about the same. Yep, I think I'm there. So we have a timer for tank 2 full. All right, then we have a sequence. And all right, F81 is tank 2 level. All right, and then that sequence, this L9:0/0 is the same L9:0 right here. We're just looking at bit 0 on it. So we should be able to just create a tag right here. And I'm going to make this one a global variable because it is also in the HMI. We're going to call this sequence. Why does it not like sequence? Did it already create sequence? Huh. Well, batch sequence. That's weird. Okay, now I'm curious. Huh. I don't know why I can't use the term sequence. I may have never tried, but hey, does anybody know? Sequence. It will not. Came up with something for a second. Oh. Well, I get to stay over it. Ah, okay. So sequence must be used internally. Oh no. Okay. I can't name it sequence because I named this program sequence or okay. So I get it now. So we'll use batch sequence. That's cool. All right. So at the beginning here, we had L9:0, which we've now made sequence, and we had /0. If we want that in Connected Components Workbench, we're going to put sequence. I'm sorry, that was batch sequence. Batch sequence .0. And that's going to be the same thing. And we can also, did that have a description? Yes, it did. So fill tank 2. So I definitely want a description of it. But you know, I think I've ran into this before. I don't think I could figure out how to add a description to a bit based off of that. Oops. So that's the, hey, there's something maybe somebody can help me figure out. Is yeah, I cannot I do not know how to add a description to this. So this is going to make this one really difficult. I'm going to have to think through that. Because, yeah, I don't think that's a good idea. So, yeah, I'm not going to do it this way. I'm going to put something in for now, and maybe somebody can tell me exactly how we're supposed to do this. Is what I'm going to do is I'm going to copy that, and we're going to make some rungs down here. And we're going to make a tag called sequence fill tank 2. And I'm going to use that. That way, whenever this sequence 0, which is what our sequencer is based off of, whenever bit 0 is a 1, it's going to make sequence fill tank 2 a 1, and I'm going to use that. That way, when I'm visually looking at this, I can tell what it is. Now, I think there's probably a way to add a description to this, but I think I worked at this one day and I could not figure it out. Because, yeah, when you get in the variable selector, unless, can I put .0 here? Nope, can't do it. Okay, so I don't know how exactly to get by that, but this is how we're going to do it. All right. So then we're looking at tank 2. So we can just type tank 2 level. And then we are looking for it to be greater than F86. And when you're looking here in Logix or Rslogix 500, you're going to see the description of the source, or in this case, source A. Now, if you're writing to something like here, you see the description of the destination. Source B, you can't actually see the description of by mousing over or anything. You've got to right-click it and either edit description or go to data table. And so this is tank 2 full setting. So I'm just going to create a tag that says that. So tank 2 full setting, and it'll be a reel. And then we have a timer, and I don't believe this timer actually is settable externally. So what we're going to do is we're going to right-click T4:0 and go to cross-reference. And okay, the TON, which is right here, is used, and then we have an XIC of the done bit right here. So it's not, you cannot externally write to this, and this was a 10-second timer. So in the case of Connected Components Workbench, I just go right here and type T number 10S. And that'll be a 10-second timer. Oops, if you put it in the right place, it'll work better. That should have gone right here. Now, I don't have to put an elapsed time tag in if I'm not actually using an elapsed tag. So in this case, we're just going to, actually, whoops. Oh no, okay. Now, one thing I didn't do is I haven't actually named this TON. So see, it went in as TON_1 again. So we want to go to local variables, find that, and in this case, this is tank 2 full. Oops, yeah, that's good. So that'll be tank 2 full, and then here I can look at tank 2 full.dn. I'm sorry, it's not .dn, it is .q in Connected Components Workbench. And that's one of those stumbling blocks. I do have a video about what all these are, but yeah, we want the q bit, which replaces the done bit in Studio 5000. And all right, then we're going to move a value to this batch sequence, and we are moving a value of 2. So we're just going to put a 2. All right, so then let's go, what's the next one here? The next one, actually the framework, it doesn't look like it at first, but this framework's very similar to what we have up here. It's kind of shifted over a little bit this way. and we have two greater thans on this one. And then also, hey, here's a multiply just like I did in the other one. And this is how I would group that one. So we're on the right track here. So let's copy and paste rung 0 or rung 1. Because this is a good place to start. So first, what is this step actually doing? It is adjusting the pH. So I'm going to go to the bottom and we're going to make sequence number 1. This is going to be sequence pH adjusting or adjust pH. Oops, and I need to create that thing. Alright, so then we can copy that, and that will go right here. And okay, in this case, we are looking for our pH to be greater than, what is F87? Our pH high setting, or, let's see, pH low setting. I'm not exactly sure why this was done like this, but yeah, there's probably a reason. But usually, this lower one would be a little different, but I can't, it's been a while on this one, so I don't really remember what was done. But okay, so we got that. So this is going to be tank 2 pH. And then we need a tank 2 pH high setting and a tank 2 pH low setting. These are both going to be global variables. So tank 2 pH high setting, it's going to be a real, and tank 2 pH low setting, and it's going to be a real. And we're going to be looking at the high there, and then we need a branch around that. And we're actually going to copy this, put it right there, whoops. And then this, whoops, did I not enter it? I did not enter it. Or am I editing the wrong rung? I'm editing the wrong rung. Alright, well that's why we have the undo key here. And yeah, we'll put our branch down here in the proper rung. And then we'll copy that, put it there, and change this to low. And then what do we have? We have a pH adjusted timer. And T401, this is that timer we've already stuck a little bit of from the scaling, yeah. T401. Okay, so yeah, this rung that we have is going to find a home now. Alright, so adjusting, and then we're going to move a value of 4 when it's done. So pH adjusting. And one thing I didn't catch is when I copied and pasted, I put the wrong one in the wrong place. Let's move that there. Let's move that there. The dangers of copy and pasting. Alright, so now this needs renamed. Tank 2 full 1 is now going to be tank 2 pH adjusting. Alright, so then this will be tank 2 pH adjusting. Alright, and we're going to move a value of 4 when it's done. Okay, and then we have a value here though. So this, in this case, we are actually getting this value from the HMI. It looks like it's in minutes. So yeah, we're going to have to create something for that. So this will be our pH. Yeah, really, this is our settling time. It's kind of pH adjusted time. pH adjusted time, I guess. That's the cool part about tag-based addressing is if I find out later that it was the wrong thing to put, we can change it. But all right, we're going to go to controller tags, and yeah, we did name that one settling time in minutes, which is wrong actually. That's settling time left. And let's make it pH settling time. How about that? pH settling time left in minutes. And we're going to create one that'll be pH settling time, pH settling setting. Geez, there's a tongue twister. pH settling setting in minutes. And that's going to be a real. It's not actually a timer tag. All right, now let's go see if we can put that in here. So first, this does have to be a time data type. So if I just type pH settling time in minutes or pH, oh, see, it's not even coming up. So there's the whole deal. These are the only ones that are optional. Or I'm surprised some of those come up though. pH setting in minutes. There it is. Okay, if we bring that in, see it says data mismatch. And that's because if we mouse over this, it says that we're looking for a time data type. And we have this as a real data type. So now what I'm going to do is I'm going to extend this branch down right here. And we are going, actually we don't even have to do that. We can put it right in line, but I think this rung's going to get shoved way out if I do. I don't want to work this. Yeah, let's just put it right in front of it. Because we're going to need that too. We're going to type any again because the any instruction is just great. We have an any to timer variable. And this one will be our pH setting, pH settling setting in minutes. I got to work on that name, but that will be it. And then, well, we're not quite ready to convert it yet. We're going to need an intermediate step here. Just realize that because this is in minutes. And we want to get this to milliseconds. Well, this any to time is going to convert whatever you have here to milliseconds. So this needs to be in milliseconds. So we need, and here's where, okay, I probably was right. This probably needed to be on its own rung. And then, yeah, we can see already this is getting, see how it's getting messy here. And one thing I don't like about about Connected Components Workbench is it doesn't kind of kick the rungs down, or it doesn't, what is it, or it doesn't wrap the rungs, or at least I haven't figured out how to make that view. So it just keeps going out to the right where you have to use the scroll bar. So we're going to just bring another rung down, but actually we already have the rung. It's right here. Here's our settling time. So we are going to actually modify this rung. And first, I am going to actually, yeah, we're going to drag this. Is that right? This is a TON. Oh, because we added that TON. That's actually the TON we're looking for there. Got to keep track of where I'm at on this. Settling time in minutes, or in milliseconds. That does go right here. Oops, no. I haven't created that yet. There it goes. Yeah, we're good there. And then this goes away. And then, yeah, we need to take this part and just move it down here. And the reason we're moving this down here is just organizational wise to keep our brain straight. Is that rung was getting ready to get way too big. And really when I'm troubleshooting it, the main thing I'm going to know is it in this step right here, and what are these values? Because that's going to start this timer, and that's what's going to get us through the sequence. This one right here is more of just figuring out some math for it. All right, but we have, where was I even then? We're going to need, okay, we have an any to time. Okay, and then we needed an instruction before because we had to get that into milliseconds. So we are going to do a MUL, or multiply. And our I2 is actually going to be this. In fact, this ends up being the opposite of what's right below it, because here we're dividing to figure out our stuff in minutes. Here we're going to multiply to figure it out in milliseconds. So this is 60,000.0. And this input is going to be that settling time. Man, I've got to rename that. pH settling in minutes. That's what we want. And then we're going to need to put it somewhere, though, just as an intermediate step. In fact, unfortunately, I don't know, there's not a real clean way to pull that off otherwise, but we only need one day. So we're going to go here and we're going to make a pH, and man, I just can't think of another term for this, but it should be better. pH setting in ms, or milliseconds. And that's still, at this point, we're still a dent. I'm sorry, we're still a real. So we're going to need that. And we're going to put it right there. And we're also going to put it right here. And now we're going to need it one more time, because we need pH setting in time. I know that's a lot of crazy setting things, but so pH setting in time. And this will be a time data type. So we're going to bring that, and then this tag is going to be right here. Okay, now one problem is this is in milliseconds. So I see already we got a yellow triangle here. I brought that in from the other program. We kind of stuck it here, but it's going to have the same thing. It's going to need this any2 to get us in something we can work with. So we're going to bring down another rung. I'm sorry, another instruction, and this will be an any2, and we want an any2 real here. Oh, and yeah, so I've got a video coming out here in probably next week. You notice the any2 reel is missing, and I don't fully understand why, but they consider in the Logix view the STOR, which is a string to reel conversion. They consider it to be the any to reel. So just be aware of that. I just figured that out not too long ago. But so this needs to go here. And man, we got to make another one of these crazy pH setting things, because now we need pH setting time left. All right, yeah. Or I'm just going to put ET in time, elapsed time in the time format, and it'll be a time. So that goes there. Then we can copy that and put it right there. And there we go. Oh, why is that got an error? Oh, why did I not do a reel on this? This should be a reel. That's a mistake on my part. So settling time in MS, the only one that actually isn't a tongue twister, oops, is wrong. Oh, come on now. So that, well, should be a reel. All right, we've done enough here. It wouldn't hurt to go ahead and hit this verify button up here, and let's just see what we might have wrong. And that's always a refreshing surprise when actually you have no errors in the program. All right, so the next one we're going to do, so we've gotten through batch sequence number 2. Now we need, number 1. Now we need number 2. Okay, and all right, this looks very much like rung 0 or rung 1. Have a little bit of trouble. These in Rslogix 500, you start with 0 on your rungs. Connected Components, you actually start with 1. But this rung is very similar to the one we're getting ready to do, so I am going to copy it. And then I'm going to come right down here and we're going to paste it. And all right, first let's go ahead and get this batch sequence in. And I'm hoping somebody will tell me a way to label these, because that's the only reason we're doing these 3 rungs down here is I need to label each one of these bits. And I just can't figure out how to do it. But this will be empty tank 2. So we're going to call this sequence empty tank 2. And it'll be a boolean. And then we can take this and put it in place of that. And okay, so first this is empty tank 2, not tank 2 full. So let's go ahead and edit it. And find that. And it will be tank 2 empty. Back here. Okay, and what does it call for tank 2 to be empty? All right, well, tank 2 has to be less than tank 2 empty setting, which makes sense. So we're going to create a tank 2 empty setting, and it'll need to be a global variable or a controller variable because we're going to set it on the HMI. So this will be tank 2 empty setting, and that will be a real. And so this will change to an LEQ. And this will be tank 2 empty setting. All right, and then this will be tank 2 empty Q. And probably this is not settable, but we're going to cross-reference T4:2. And yes, it is only used right here, this little bit. So there's just a 10-second delay, just to probably there was probably some turbulence in the water, so it was just to make sure that it was actually reading okay. So first, that goes right here. So all right, it already is. That one's set to 10 seconds from the first one. And then what are we moving? A value of 4? Oops, I think I may have skipped one, or did I? Let me double check that one. We're moving a value of 8. So move up a little bit. Ooh, I missed did I? No, okay, it's right here. 4. That's the rung we added. So then we're going to have 8. Okay, and then what do we have? All right, and I mean, that's why I thought this program was really good. We just went through a really basic 3-step sequencer, and really with a little bit of massage, and you should be able to put this into your trainer and make it work. But okay, in these conditions right here, we're really going to just reset our sequence. And okay, it looks like there's a button to reset the sequence. We reset it on power up. We reset it, actually, if it's, and I say reset's not the right word. The sequence starts at 1. So if we have a value of 0, or mainly we're less than 1, we're going to move a 1 to it. And then, yeah, if we're greater or equal to 8. So when we get to 8, which means our tank is empty, the process starts over. All right, so we need to add 3 branches here, 2 over here. We're just going to start building the structure out. So run down. And we're going to bring a couple branches, and then we're going to click the bottom of it and right click Oh, come on now. Why does it not let me grab that? I think I have to actually put something in there usually to grab that. So yeah, we'll go ahead and put something in. Just bring an instruction block down. And now we can probably, yeah, now we can insert it. So below, need one more. That gets us close. All right, then we have greater than or equal to, a less, and 2 XICs. So GQ, the instruction block for a less, LES, and then we have that. Up here we had an unlatch, and we had a move. Okay, and I think all these have to do with our batch sequence. So we can copy that batch sequence, put it right there, and put it right there. And if it was less than 1, or if it's greater than 8, and then we have first pass. You know, we'll have to, there we go, power up bit. My wild guess is that is it. Let me see if I can Google real quick. But I believe that is our first pass. Well, I may have to look at that a little more. I'm pretty sure that's the first pass. Well, let's see what our other options are. Project incomplete, suspend ID. I feel that probably is. Probably good. Yeah, let's just see if maybe F1 helps us on that. Okay, so yes. F1, and then I searched over here for that bit, and yeah, it is true only on the first scan after a power up or running new ladder for the first time. So that is the bit we're looking for. So that way every time we cycle power it starts over. And that last one was it just called sequence reset? Yeah. So we're going to make a global variable because this is on the HMI. It says sequence reset, and it will be a Boolean tag. So sequence reset, and we'll have that same, that's what it's unlatching over here. That way the HMI puts a 1 there, and when it's done resetting, it sets it back to a 0. Sequence reset. And then in this case, we're going to be moving a value of 1 to the batch sequence. All right, so that takes care of our sequence. Let me make sure before I jump the gun and say that. Yeah, so that's the end of that one. And now what are our outputs? But yeah, I didn't actually think about it, but this one's good because somebody asked recently how to do HOAs in an HMI. And this is how I would do it in Connected Components Workbench, although I wouldn't, again, I'm not going to use N7:0 for it. I'll probably create an array. Yeah, I'll create an array of integers, and that's how we'll do it. So let's go ahead and start that. We're going to go over here and we'll open up our outputs. And you know, just for housekeeping, I'm going to close all these. Ooh. Well, I was getting ready to save, but let's make sure we save everything. But yeah, mainly, I haven't saved this at all while we've been doing this, so I probably ought to hit that save button. All right. So we had an equals, and then we had a branch, and we had another equals, And then in the bottom rung, we had an AFI. AFI. Now, an AFI is an always false input, and that means no matter what, it is going to be evaluated as false. And this is more of a place marker. In fact, hopefully it's not a lot of them. Yeah, output 0 wasn't used for some reason, or it got removed or not. Oh, yeah, output 0 on this one had some high speed uses, and I was probably thinking we would add some high speed output for something. So I left it open. But all right, then we're going to energize our output. So we'll go right here. And we're going to go to our I/O tab, and there we are, spare 0. And then we need to create a tag for this. And here's where, yeah, I don't think I create one for each one of them, but okay, we have 20 outputs, 0 through 19. So I would create a tag, let's just call it HOA outputs. And this is going to be an int. But then for our data type, oh, my mind's going blank on how to do this now. I feel like I'm getting ready to do something wrong. So this is probably wrong, but that's how you do it in Studio 5000. But yeah, it doesn't like it. Because I know there's some dots required. And we're probably going to have to hit F1 to figure this out, because is that it? Oh, there it is. Okay. Oh, okay. In this, you can specify the beginning and the ending, which is kind of cool. In our case, we are going 0 through 19. So we're going to do 0 dot dot 19. And that's going to be our HOAs. So we end up with 20 of them here. So this will be output 0's HOA. This will be output 1's, 2's, 3's, and so forth. So now let's go over here. And we'll just put HOA output, and then open bracket 0 close. So this is going to be the one that controls output 0. And you know, I go back and forth, and a lot of times I will build out the structure for all the outputs. In this case, I'm not going to. I'm even putting this one in because it was the first one. But I probably will stop short one because we're streaming this. But all right, then we have a value of 1 and a value of 2. So right here, we're going to put a 1. Right here, we're going to put 2. And what this is going to say is if our HOA, first, if it's a value of 0, there is no true path through. And so all for my HOAs is 0 on the, and then if we have it as a value of 1, it's hand. So you switch it to hand, it's going to be a value of 1, and that's going to make output 1 come on. And then we have 2, which is going to be auto, and that's going to make it run whatever the auto sequence is. And since it's a spare, we have an AFI in it. So we're going to just copy and paste that, and then get to something that actually has it. Okay, well, and the second one, of course, is an exception because it's the alarm light. Now, why did I do the alarms this way? That's the grand question. It looks like is there warnings and alarms here? Let me just see. So we're going to cross-reference. Actually, let's just go to the data table. And go to usage. Well, I have no idea why I did it this way. But I did. But we're not going to do it this way this time. We're going to create... Do I want to do that? Yeah, I do. So we're going to go to our controller variables, and we're going to create a tag called alarm bits. And this will be a dent. And so that's going to give us 32. Ooh, that's going to give us 32 bits. And why was I able to open this one up? Now I still can't comment it. I still would love to figure out how to comment the individual bits. But okay. Moving on before I end up in a squirrel moment here. Go back here. In this case, for this one, this is our alarm light. Output number 1. And we're going to take this out. And over here we had these 4 branches. But we can actually just, in this case, I don't know why I didn't. I could have looked for B3:4 to not be 0. Because if any of these are on, it's going to be 0. And that's what I'm going to do on this one. Is we're just going to change this to an NEQ, or not equal to 0. And we're going to look at our alarm bits. And that'll make our alarm light come on whenever any of our bits are on. Okay, so number 2. Oh, and here's, so I sat there and explained the HOA and said, let's move on to something that where it'll make sense. But yeah, the next 2 are not. But okay, then we go, all right, now we're actually showing some stuff. But all right, we're going to do the alarm buzzer next. And okay, it has an alarm silence on it. So we're going to need to create a bit for alarm silence, and that's a button. Oh no, okay, it was a button on the screen. Okay. So, in this case it's on the screen, so it's going to come down here. It'll be alarm silence. And bring a rung down. And first, yeah, let's just build the structure out that we have. So we got a branch, examine off, and an output energize, and then we have a branch. And then we have, oh no, the alarm silence is a physical input, okay. Let's see, examiner close, 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 and output energize. Closed, closed. Okay, and in the end, this turns on output 2, so it's going to put that in. We have alarm silence, so this is alarm silence. And then we have alarm light. Actually, I have alarm light in both of them there. I think I could have cleaned that up a little more, but you know, I think I said that we're going to start doing some on looking at some of old programs, and I'm going to nitpick mine probably first. That way, nobody thinks I'm being cruel. But yeah, even looking at this, I could have done a lot of things different. But it is a functional program. But yeah, it looks like there is some room for improvement. Okay, so we have the alarm silence button or alarm silence. So now, alarm silence. So you notice there, I didn't have to type this long thing. That's one thing I do like about Connected Components is, you know, one, you can use spaces. I mean, you can have a really legible description or alias. It's not, because it's not exactly the same as an alias in Studio 5000. Well, that's what they label it as, but it really works smooth on that. But okay, that takes care of that rung. Next, let's bring down another rung. And honestly, I'm going to skip this next one. It is a spare rung. Oh no, it's not going to take long. I can copy and paste it. So yeah. Just click there, copy and paste. And then we'll bring this down. Oops. Well, why is it not letting me drag? My scroll isn't working. Okay, so this will be number 3, which is a spare. But then this is going to be 3. And I'm just building the structure out. Really, there's not, honestly, I don't think there's a tremendous amount of reason to. But I probably, when I was writing this, I probably expected these to be something. And for some reason, they didn't end up being anything. But okay, now we're going to go, all right, now we have Huh. Okay, this pump, it's like this pump occasionally circulates. Looks like every 3 minutes or 300 seconds, it runs for 30 seconds. So this is a flash on, flash off that we've done some before. But all right, let me make sure where this is used. Okay, and yeah, so it is used to run this pump occasionally. So probably the system had a little bit of issue of settling, maybe solid settling in it. So to keep it from clogging up, just occasionally you turn that pump on. Okay, so we have pump one. Let's call this, let's see if we can not into that settling thing again. This will be pump one, circulate on, and pump one, circulate off. And that's, so we'll just make some local variables for those. Let me close some of this up. Actually, it's okay. So we're going to have pump one, circulate on, and it'll be a timer. And we're going to have pump two, or no, pump one, circulate off. Should have thought about this. Is not the right. This isn't how I would do that. I would create the TONs normally. Let's just take them back out. And yeah, all right, bring down the rung and just start building the structure out for it. So we would have examinative open. We're going to have a TON. And then we're going to have an examine closed. And then we're going to have a TON. All right, now I would go here to local variables, which actually, let me go back there so we can see it. Is we end up with TON1, TON2. This is our circulate on, this is our circulate off. So this will be pump 1, circulate on, and this will be pump 1, circulate off, circulate. All right, so now they come in, and so this will be pump 1, circulate off, dot Q. And this is going to be pump 1, circulate on, dot Q. And let's make sure. So yeah, pump 1 off, turns on the TON, pump 1 on, circulate. Actually, yeah, I'll just spend some time probably. This is a really difficult one for a lot. Yeah, all right, circulate's a difficult word. I spelled it wrong there. This is a difficult program here for a lot of people to understand. They know it works, and this is how we make flashing lights. This is how we make cascading timers. We make all types of neat things with them, but a lot of people really don't know how they work. But okay, we have, looks like neither of these are settable. Let's double check. So cross-reference. Okay, we're using the TT. Mainly, I don't see a PRE or a preset over here. And we'll double check this one. Again, yeah, no preset. So we're not changing this time. So we're 30 on, 300 off. So go over here. And this will be T number 30S. And this will be T number 300S. Or, no, since we know, 300S, let's make sure we understand that's specifying seconds. Now, there's 5, this is actually 5 minutes, so 300 divided by 60 is 5 minutes. So if I know it's 5 minutes and I don't want to do the math, I can just put in 5M. And that's going to be 5 minutes. So this will be 30 seconds on, 5 minutes off. And really this, so again, going back to you know, these automatically converting programs compared to at least going through it. Here's a good example. This is so much clearer, 300 seconds on, 5 minutes off, compared to 300 or 30 seconds on, 5 minutes off, compared to 30 seconds on, 300 off. I mean, yeah, we can figure it out, but there could be some crazy number in that 300 spot, and that's where, yeah, this just works really well. All right, that takes care of that. So our next rung, I believe, is actually where I was hoping to get to show you the HOA. Okay, so yeah, now we're finally to something halfway functional. Because yeah, even this one, this has to do with the valving. But all right, so we have an EQU, and this is our HOA. And then, oh, okay. So we have an interlock. So what this is pump 1 can run to tank 2, or it can run to tank 1, depending on the valving of it. So we have to have a little time to make sure that the valves shift. But all right, HOA for output 4. And let's just start building the structure out. So equal XIC, couple greater thans, an XIC, and an OTE. So equal and then a greater than, and we have a branch around it. We have another one, and then we have an XIC. And then we have an OTE. Oops, wrong OTE. It's a negated one. Okay, did I actually get all that? Let's see. Equal, greater, greater. XIC, I think that's close. Yes, it is. Okay. So we're going to be at HOA output number 4 and sequence fill tank. So HOA outputs number 4, and then this will need to be a 2. I think that was 2. Was that 2? Yep, 2. Oh, whoops! I left an XIC out there. And so this will be sequence fill. Oops, my guessing isn't working. I don't remember what it is, so we're going to have to go up here and look. Yeah, sequence fill tank 2. I don't know why I couldn't find it, but there we go. Ooh, because so I made a mistake. I sat here and I made all of the sequence outputs, even though I made the sequence a global variable, I did not make these global variables. So these these 3 need to be global variables. I wonder if I can just cut them out. Can I cut them? Says I can. Let's see if I can just paste them up in the controller variables. Yes. All right, so now we got outputs. So just so we understand what happened there, yeah, if you have a local variable, you can only access it from the local program. If we have a controller variable, we can access it from any of them, and it's easier at least to access them from the outside. So that's what we did there. All right, now we're looking for tank 1 level is greater than, what are these? Cross reference. Tank 1 start pumping setting. Tank 1 stop pumping settings. So let's create those 2. These will be controller variables as well. Tank 1 start pumping setting, and it'll be a real. Tank 1 stop pumping setting, and it'll be a real. All right, so we're looking at tank 1, so we just type tank 1 level. And then right below that was tank 1 start pumping. And then tank 1. And then tank 1 stop pumping. And then, alright, we have run pump number 1, pump 1 to tank 1. Okay. I don't think I can simplify that either. That is what it is. So that will be run pump 1, tank 1 to, oops, tank 1 to what? Make sure I am. Tank 1, pump 1, run pump 1 to tank 2. How about run pump 1 to tank 2? Let's simplify a little bit. I think it's still clear. Run pump 1 to tank 2. And that'll be a boolean. And we'll take that same tag and we'll put it right there. All right, then I think we're finally to the HOA that I was like, yeah, well, we'll explain that in just a second. All right, so yeah, here is more of what you would typically see on the HOA. And I probably should do a video just about this. So in this case, we're on number 4, which is pump 1's HOA. And first, if it's 0, there are no true conditions that will go through. So our HOA in position off, or HOA, I'm assuming you know what that means. That's a hand off auto. In the off position, it's a value of 0. So we can never run pump 1. And so 1 is hand, and so you'll see it with almost nothing else in it, usually nothing. Because I kind of believe hand is hand. You put it there, you take the risk of burning whatever up. And then you have auto, and it's going to have whatever conditions you happen to need to run in auto mode. But all right, so now we should be able to copy and paste that first rung and give us a little bit of structure to work with. So I'm going to copy this. And then we're going to paste it here. Oops, pasted 1 too high. All right, so this is output number 4. So this will be HOA 4. This is HOA 4. And this will be number 4. Okay. Now, honestly, I don't know if there's a lot to gain in actually showing this, because at this point we're getting pretty redundant. I mean, there is more conditions here, and maybe we could do a video on how exactly this works if somebody's really interested, but this is a conversion. So I think we've kind of shown the conversion through there. The last thing we really have is the alarms. Let me just browse through here, see if anything really jumps out. Now I think we've covered all this. Yeah, so now let's just go to the alarms, because yeah, I can do the rest of this offline. But mainly let's just see what else there may be to cover. But okay, here, yeah, let's go through these alarms because these are all really good ones to have. As first, this has separate control power, or has separate PLC power compared to its control power. So one thing, that way your PLC is up if, say, you short out an input. So one thing you want to know is that input on or off? And that's what we're doing here. Is if there's no control power, then we're going to make an alarm for it. And we do have a delay on most of these because you don't want, if you have an erratic problem, you really don't need 100 alarms a minute. But also, yeah, it just helps with, operators they want to know when something's wrong, but they don't want to know, you don't need to nuisance indicate to them. So let's go ahead and put this in. So we're going to be in our alarms program now. Okay, and already we had the downstream analog we stuck over here, and that probably does fit here. We'll put this above it though. And let's examine if open. And again, I don't remember what input that was, but I know I think I labeled it as no control power, so I can just start typing no and maybe get lucky. No, I'm not going to get lucky. Nope, didn't get lucky. Okay, well then we will either look here, it's input 5, and then we'll, 24. 24 volt power, okay. So there's that. And then we're going to need a branch. We need an output. This will be a TON. And so here's an example. I don't particularly care about this TON anywhere else. So I don't know that I really need to name this one. This one, in this case, I would leave it just as TON1 because it is localized just to this area. So we're going to put T number 5S, and we're going to put TON1.Q. And in that case, we made some alarms. Let me see if I can find it. We made alarm bits, and that's going to be .0. So this way, if our control power drops out for more than 5 seconds, we're going to sound an alarm, and it'll be alarm bit 0. Still would love to have a description on bit 0, and I don't know how to do that. All right, we're going to copy and paste that wrong. And we do have to be careful when we copy and paste there, because see the 2, if we were really, yeah, we just need to be careful about that, because notice the pasted rung went above it and it has the 2 in it. So this no longer works. We want to drag this down. And yeah, this one is going to be 2. Now I'm not really that OCD that I want this to be 1, 2, 3. If you are, you need to label them as something other than that, because yeah, as we copy and paste stuff, then we could end up with one somewhere else that's not going to lay out that pretty. But all right, what do we have here? So this is tank 1 high level, and we're looking for tank 1 to be greater than, probably tank 1 high level settings, my wild guess. Tank 1 high alarm level. So in this case, we're going to bring down a greater. This will be tank 1 level, and this needs to be a global variable because we're going to set it on the screen. Be tank 1 high alarm setting. High alarm? Yeah, that. No, actually, I would do tank 1 high alarm level. That way we know it's a level. Real. Okay, and that was 10 seconds on that one. All right, then we have that. And is there anything else to really learn? I think we can figure that rung out. This is more of the same. Looks like this one, the alarm is settable, but that's doable. All right, and we are, now here's another one of those I have not figured out how to do in Connected Components. So in this case, and actually it may not be that necessary in Connected Components, but it is here. In this case, I copy the input word, which is the 16 bits of inputs 0 through 15, to a binary integer, or an integer with binary format. And you can't do this in Connected Components that I know of. In other words, I cannot specify our inputs to the word level. Because if I go over here to my controller tags, really, they just start being listed. So either you can't do it, or maybe somebody can show me. Maybe there is some hidden way to address. I don't know. What happens if I address IOEMDO? No, it's going to come up as a bad address. So I don't know how to actually do this. But what I'm doing here is, it seems like with some HMI I was using, you couldn't directly read inputs and outputs. I think that's what was going on. That's how I started this. But in Connected Components Workbench, you can directly read inputs and outputs with an HMI. So this actually is fairly unnecessary. Let's see. And actually on the HMI, we show where the water's going when the pumps are on and things are happening. So that's all this is doing, is different conditions or making different ones come on. But I don't think there's a lot to go there. And actually, that would make good for the HMI series, though. Maybe I should build this out a little bit in the HMI series, and then we can show how you can, graphically show that our pump is kicked on. Change your pipe color so everybody knows water's flowing through it, or put some arrows that are kind of going along. It would be a good thing. But okay, so I have gotten through my first live stream, and yeah, okay, I had down that should take about 2 hours, and we're at 12:56. Yeah, well, and we were 7 minutes late because my technical guru Michael was not here to fix my sound issue or my streaming issue, but we did get online, and I hope this has been helpful. If you'd like to see more of these, then let me know. Put what you'd like to hear it on or anything like that. And yeah, make sure you subscribe and hit that like button. Till next time.